Hello everybody, we're going to go ahead and look at Unit 3, Lesson 3 today, one-to-one functions and their inverses. So today we're going to determine if a function is one-to-one and find the inverse of a function. So to be one-to-one, the function must pass what we call the horizontal line test. So what does the horizontal line test? It's very similar to our vertical line test. Instead of vertical though, we have a horizontal line. So if I do that perfectly horizontal, and if you were to go up and down along a function, it would only touch one point at a time. Okay, and what this means is your x and y values, none of them repeat. Okay, so here's a little example. This is an example of a one-to-one function. The reason being, my x values, I got 4, 3, 2, 1. None of those repeat. And then if I look at my y values, none of those are the same either. Okay, so that is a one-to-one function. No x values repeat or y values repeat. Now here's an example of a function that is not one-to-one. If I check out my x's, those are all different, so that works. However, if I look at my y's, 2 4s. Okay, so as soon as there is a double repeat of a y value or an x value, it is not one-to-one. Okay, and if an x value repeats, that means it's not a function. Okay, just going back to the vertical line test. So example 1, is the function one-to-one? So we do the horizontal line test. So what I would do is draw myself a horizontal line. And if I were to be able to take it and go up and down along here, does it touch more than one point at a time? Yes, it does. So that means it fails the horizontal line test. So we fail the HLT, the horizontal line test. So is this one-to-one? No. Here, go ahead, draw myself a horizontal line. Did not do a very good job of drawing it straight, but there you go. Horizontal line test. If I go across here, am I only touching one point at a time? Yes, I am. So it would pass the horizontal line test. So is it a one-to-one function? Yes, it is. Example 2, is the function one-to-one? Well, some of you might know what these look like off the top of your head. If you don't, you can graph them on your graphing calculator. So let's go ahead and do that. So I would go to my y equals, and I have x to the third power. And I think, was it +1 or -1? -1. And what I would do is go ahead and graph it and see what happens. So if I graph this, there's my function. And if I were to have a horizontal line, I would go across and I would check. Okay, right here, it looks like maybe it would fail the horizontal line test. But if we go ahead and zoom in right at that spot, I'm gonna go ahead and go down here. It's kind of hard to see, but it will gradually increase at all moments. And if I were to continue to zoom in here, you guys would see that that would be the case. So zoom in a little bit further. Can you guys see it's always going up, up, and up? Okay, so it's going up and up and up. So it would pass the horizontal line test. So is it a one-to-one function? Yes, it is. That x cubed kind of throws people for a loop sometimes. The next function we have is x squared plus 3. So let's graph that one and check it out. X squared plus 3. And I'm going to change my window back to normal. The way you guys get your window back to normal is zoom number 6, the standard. Get you back to -10, 10, -10 to 10. Horizontal line test. If I were to run a horizontal line, would I pass? No, I would fail. So x squared functions, they do not pass the horizontal line test. So that one is no. Inverse function. So if a function f of x is one-to-one with a domain A and range B, then its inverse function, f inverse of x, has a domain of B and a range of A. So we got a whole lot going on here, but inverse functions, the way you guys find inverse functions is we end up switching our x and y's eventually. So typically we plug in an x and we get out a y. Okay, now if you have the inverse, you're going to plug in a y and you get out an x. So what does that do with our domain and range? It swaps them. Okay, so our domain becomes now our range, and our range from the original becomes our domain of the inverse. Okay, so our domain and range switch. So this is our inverse notation. Okay, so example 3, assume f to be one-to-one. Okay, find the values. So what this is telling me is when I plug in 1 for x, I get out a y value of 5. When I plug in x equals 3, I get out a y value of 7, and same thing here, xy. So now what this is telling us is f inverse is typically f inverse of y equals x. So this is telling me my y value is 7. So what would I get for an answer for that? So what I would do is look for a y value of 7, so right here. So what x value does that give me? 3, because my x and my y's switch. Same thing here. This is really f inverse. This is a y value. So what x value gave me an answer of -10. So f inverse of -10 equals, so right here, my x is 8. This only happens, you guys, if it's 1-to-1, okay? Because each x has to be mapped to each y. Okay. If it's not 1-to-1, you would not be able to assume this, or not assume this. You won't be able to guarantee this, I should say. So f inverse of y equals x. So my y value here is 8. Well, this is an x and this is a y, so this would be equal to 3. And then this one's telling me my inverse. So this is f inverse of y equals x. So now this is telling me my x is -1. Okay, what's our y value going to be? -3. So there is example 3. 4, a little bit more complicated because we're dealing with functions, but not too bad. So it's just telling what the notation is. So if I have f inverse of 7 equals x, this is really my y value. Okay. So what we're going to do is I plug in 7 for y and I solve for x. So 7 equals 2x minus 1. And then, whoops, solve for x. Let's try that again. 7 equals 2x minus 1. I solve for x. So I would add 1 to the other side. So I have 8. And then divide by 2. So 4 is equal to x. So f inverse of 7 equals 4. That's what the x value is. I would like for you guys to pause the video and try f inverse of 10 on your own. Okay, hopefully you pause the video. Let's go ahead and try f inverse of 10. So this is my y value, okay? And so I would have 10 equals my function 2x minus 1. So I'd add 1, so I get 11, and then divide by 2. So I have 11 over 2 equals x. That's an acceptable answer. You could also say 5.5. Okay, so f inverse of 10 equals 11 over 2, or 5.5. Both are correct. All right, B, another equation, same type of idea. F inverse of 3, so it's just telling me a y value. So I would say 3, plug it in for f of x is the same as y, so 3 equals 2 minus x, and I would solve for x. So I would subtract 2, so I get 1 equals -x, and then divide by -1, so I get -1 equals x. So my conclusion for that one is f inverse of 3 equals -1. Okay. Here I have f inverse of 0, so that's my y value. So I have 0 equals 2 minus x. So I'd add x to the other side, so x equals 2. So f inverse of 0 equals 2. Okay. Example 5. The ordered pairs of the relation are the vertices of a right triangle. Find the inverse of this relation and then graph the two relations. Okay. So inverse of this. So here's the relationship with my right triangle. The inverse. What's going on with our inverse each time, you guys, is our x and our y values, they switch. Maybe here's a little bit easier to see. Here's my function. I had 1 and 5, and then the inverse of that one, no, we didn't do that here. Let's do this one. We have 3 and 7, and then the inverse of it is 7 and 3. Your x and your y values switch with your inverse each and every time. Okay, so my inverse functions, instead of having the point 2, 1, I now have the point 1, 2. Instead of having the point 5, 1, I now have the point 1, 5. And then 2, -4, I flip those, so I have -4, comma 2. So let's go ahead and graph this. I'm going to graph my original relationship in green. So I have 2, 1, 5, 1, and 2, -4. So here's my original relationship. Let's go ahead and graph my inverse now. I would have 1, 2, 1, 5, and -4, 2. So this is my inverse relationship. Should still be a right triangle. Okay, if I could connect these perfectly, you'd see that. And they should be the same shape. Looks like I maybe got carried away here. Did I? 1, 2, 3, 4. No, we're good. Nope, they're the same. Okay, and so one thing I just would like you to point out is whenever you guys graph an inverse, it'll always go across the line y equals x. So when x is 1, y is 1. X is 2, y is 2. We have this point the whole way, so we have this dashed line. This is the line y equals x. Has a slope of 1 and a y-intercept of 0. So if you take a look, you would see that. My inverse always goes across that line because the line is y equals x. And what happens with your guys' x and your y's? They get swapped. Okay, so if I switch them around, they're going to go across that line y equals x each and every time when I graph an inverse. All right, our last type of problem is to actually find the inverse of a function. Okay, so the first thing I would do instead of writing f of x, the equivalent to f of x is y. And now, whenever you're finding the inverse, your goal is to get x by itself. So get x equals. Okay. So what I would do to make that happen is subtract 2. And then in order to get x by itself, I would divide both sides by 3. So x is equal to y minus 2 all over 3. So f inverse of y equals y minus 2 all over 3. So when you guys have an inverse, you need to know that when this notation tells you plug in a y and you get out an x value, okay? However, when we actually write the final answer, a lot of textbooks, a majority of them, like to write it in terms of x's. So you rewrite this with x's in them. So it's x minus 2 all over 3, okay? This notation tells you, though, that you are plugging in a y value, okay, and you get out an x. That's what the inverse means. Okay, so there's that. This is a great answer. Another equivalently great answer would be to divide each one by 3. So we'd have x over 3 minus 2 over 3. Both answers are great. This is f inverse. Okay, so there's example 6a. 6b, find the inverse. So I got y equals 3x squared minus 1. And then I get x by itself. So I'd add 1 to the other side. I have 3x squared, and then I would divide both sides by 3. So now I have y plus 1 divided by 3 equals x squared. Now in order to get x by itself, I would take the square root. And remember, when you take the square root, we have two answers, plus or minus. Okay, so x is equal to plus or minus the square root of y plus 1 all over 3. Okay, and then we just go ahead and write our answer. Here is, technically, we're plugging in y's, so it's plus or minus y plus 1 over 3, okay? But the way we write our final answer is to switch it up to have x's, okay? Plus or minus the square root of x plus 1 all over 3. Same thing, you could divide each part of here by 3. I would take that answer as well, okay? So there's example 6b. C, why don't you pause the video and give this one a try? Okay, hopefully you paused it. Plugging in y. In this case, I would multiply both sides by 2. So I have 2y equals x to the 5th minus 3. To get x to the 5th by itself, I'd add 3 to the other side. So I have 2y plus 3 equals x to the 5th. And now in order to get x by itself, we take the 5th root on both sides. Okay. So x equals the 5th root of 2y plus 3. Sorry, I just rewrote the order. Now when I take the 5th root, the biggest thing, you guys, is you only need, you don't need a plus or minus. The only time you need to do a plus or minus is if you take the square root or the 4th root or the 6th root of any even degree. Okay, so if it's an even number here, you got to write the plus or minus. If it's an odd, you don't. Okay, so x equals, so we really have f inverse of y equals the 5th root of 2y plus 3. Okay, my inputs is y. We're plugging in y, so our answer would be out as x's. However, once again, we just go ahead and rewrite it to have x's as our final inverse notation. So that's the way we write an inverse at the end. 2x plus 3. All right, so there's example 6c. Last example, okay? This one looks a little bit tricky. It's not too bad. The process for solving problems that have more than one x in a fraction is the same every time. You just have to practice it and how you would go about doing it. It's a little bit more work than the other ones. Okay, so the first step is writing this as y equals. Now I know you guys don't appreciate fractions, so let's go ahead and get rid of it. I'm going to multiply both sides by x minus 2 to get rid of that fraction. This cancels. Then I'll distribute my y. So I have xy minus 2y equals x plus 3. All right, now here's where a lot of people get to, and then they're like, what am I doing? I forget what I'm doing. Well, your goal is to get x by itself, okay, to get an x equals. So right now I see two different x's. So what I'm going to do is get anybody with an x to one side and everybody else to the other side. So I'm going to move this to my left-hand side by subtracting it because it's currently positive. So I have xy minus x equals. This is a negative 2y, so I'm going to add it. So I'd have 2y, and then this will stay, plus 3. Now here's the trick. I'm trying to get x by itself. Once it's all to one side, I can factor out my GCF of x. GCF, greatest common factor, okay, of x. So we will have x parentheses y minus 1 equals 2y plus 3. And then once again, what's our goal? To get y equals, okay, so I would divide both sides by y minus 1. So I have x equals 2y plus 3 all over y1 minus 1. This is really f inverse of y. Plug in y's, and I'll get out x's. But for final answer's sake, we always write it with x's. Okay, so we have 2x plus 3 all over x minus 1. Once again, just remember, you guys, if it's an inverse, you are plugging in a y value and getting out an x. But there is our inverse for example 6D. Okay, and that is it for Unit 3, Lesson 3. Go ahead and finish or complete the worksheet. If you have questions, let us know. Otherwise, have a great day.